Now let's talk about multiplying and more difficult dividing problems with radicals. Multiplying binomial radicals together is going to work the same as multiplying together any other binomials. We use that FOIL method, or you start by distributing the first term to both the terms in the second binomial. So you get 4 times 5 is 20, plus 4 times 4 the square root of 2 is 16 the square root of 2. Now I'm going to distribute the 2 the square root of 2. 2 the square root of 2 times 5 is 10 the square root of 2. And 2 the square root of 2 times 4 the square root of 2 is going to be 8 the square root of 4. Remember that when you are multiplying, you can actually multiply together the terms that are under the radical. Alright, now I've got some things going on. One of them is that these are like terms. And this is really 8 times 2, which is 16. So that makes these like terms. So 20 plus 16 is 36. 16 the square root of 2 plus 10 the square root of 2 is 26 the square root of 2. And that's the final answer, because you cannot add the 36 with the 26 square root of 2. They're not like terms. Alright, we're going to try this again. 3 minus the square root of 7 times 5 plus the square root of 7. So we're going to FOIL. I'm going to start by distributing these. 15 plus 3 the square root of 7. Now I'm going to distribute this. Watch that negative. It's going to be negative 5 the square root of 7 minus the square root of 49. So these are like terms. The square root of 49 is 7, so these are like terms. So 15 minus 7 is 8. 3 the square root of 7 minus 5 the square root of 7 is negative 2 the square root of 7. Just like with imaginary numbers, radicals have something called a conjugate. Let's do a review of the imaginary numbers. A plus bi, its conjugate was a minus bi. So if I had 4 plus 3i, and I multiplied it with its conjugate, 4 minus 3i, we found out that the answer was a real number. We got 16 minus 12i. Now let's distribute this, and I get plus 12i minus 9i squared. These are opposites and they cancel. I squared is negative 1, so this becomes 16 plus 9, which is 25. It's the fun thing about conjugates. It made the i's go away. Well, now let's go do this again in terms of radicals. The conjugate of a plus the square root of b is going to be a minus the square root of b. Or sometimes we'll do this, the square root of a plus the square root of b, its conjugate will be the square root of a minus the square root of b. Either way, make the second term the opposite, and that will solve our problem. So now, let's see what happens when we multiply conjugates together. Alright, I'm going to multiply 5 minus the square root of 7 times 5 plus the square root of 7. And I'm kind of going to expect that the same thing's going to happen with radicals that happened with imaginary numbers. The radicals will probably go away when I multiply conjugates. So I'm going to distribute, and I get 25 plus 5 the square root of 7. And then I'm going to distribute again, and I get negative 5 the square root of 7 minus the square root of 49. Look, these are opposites. The square root of 49 is 7, so I get 25 minus 7, which is 18, and it went away. Let's do this again with a problem that has two radicals in it. Okay, first I'm going to distribute the square root of 3. So get the square root of 9 minus the square root of 6. Remember, because I'm multiplying, I can multiply the numbers underneath. And then I'm going to distribute the square root of 2, so I get plus the square root of 6 minus the square root of 4. Look, those are opposites, they cancel. The square root of 9 is 3, the square root of 4 is 2, there's a minus sign in front of that. The answer is 1. When you multiply conjugates, when you're dealing with imaginary numbers, the imaginary components go away. And if you're dealing with radicals, the radicals go away. The reason this happens is because really what we're doing is the difference of two squares. We keep running across this, and we will continue to run across it, so much so that my pre-calculus kids also see it all the time. When you multiply conjugates together, that's really what the difference of two squares is. It says when you multiply conjugates together, you just get the square of the first term minus the square of the second term. That's what's happening. So when we did 5 minus the square root of 7 times 5 plus the square root of 7, we were really just squaring the 5 minus squaring the square root of 7, which was 25 minus 7. Or the same thing with the square root of 3 plus the square root of 2 times the square root of 3 minus the square root of 2. Because it's just a difference of two squares, we were squaring the square root of 3 minus squaring the square root of 2. Well, that's just your 3 minus 2 because the radicals and the squares cancel each other and they go away and you end up with 1. We've already talked about rationalizing the denominator when we get rid of a radical in the denominator. This one you'll probably like it a little bit better because it's actually a little bit easier even though it's the same amount of work. Sorry. If you have an expression in the denominator that has a plus or minus sign, to get rid of the radical in the denominator, you're going to multiply by the conjugate. Well, the conjugate of square root of 5 minus the square root of 2 is the square root of 5 plus the square root of 2. Remember, you're going to multiply both the numerator and denominator by the same thing because that fraction is equal to 1. So what you're doing is you're multiplying by 1, which really doesn't change the problem. It may look different, but it's not different. Okay, so now in the denominator, if you want to still continue to FOIL, you may, but I want you to move into the point where you recognize that conjugates, when you multiply them, will always be the square of the first term minus the square of the second term. However, if you FOIL it and you cancel the middle terms and simplify, you will get the same answer. In the numerator, I'm going to distribute. I'm going to get 3 the square root of 10. Remember, I'm multiplying. That's why I multiplied the numbers under the radical. Plus, oops, sorry about that. Let's go back a page. Plus 3 the square root of 4. All right, so now the numerator, 3 the square root of 10 plus, well, this is 2, and 3 times 2 is 6. And then the denominator is 5 minus 2, which is 3. So 3 the square root of 10 plus 6 in the numerator and 3 in the denominator. Oh, wait a second. I bet there's a little bit more simplifying I can do. Look at that. These 3's go away. 3 divided by 3 is 1. And 6 divided by 3 is 2. So here, to get rid of an expression with radicals in the denominator, you're going to multiply by this thing called the conjugate. The conjugate will always make the radicals go away. You'll probably just have to do some multiplying and simplifying in the numerator, which is fine because that's what we've been practicing. I'm going to do an extra, and I call it complicated problem, because this is one I actually opted not to give you in the homework. So I decided I'm going to do it here. The reason I called it complicated is because one of the things that I want you to recognize is that the radical square root of 8 is not completely simplified. That's because you can divide 8 by a perfect square. So before I do anything, I'm going to simplify that radical. Alright, so the square root of 8 is the same as the square root of 4 times 2, and the square root of 4 is 2. So the numerator becomes 3 plus 2 the square root of 2. Remember, the square root of 4 is 2, that's why there's a 2 in front. But there was a 2 under the radical I didn't circle, it stayed. In the denominator, when you simplify this part, you're going to get 2 times 2 the square root of 2, which is 4 the square root of 2. Now this is a little bit nicer. Now I'm going to go and multiply by the conjugate of the denominator. The conjugate of the denominator is 2 plus 4 the square root of 2. Alright, in the numerator, I have to distribute or use FOIL. I get 6 plus 12 the square root of 2. 4 the square root of 2. Oops, I'm running out of space here. Hold on, let's go back and write this underneath. Sorry about that. Let's see, 6 plus 12 the square root of 2 plus 4 the square root of 2 plus 8 the square root of 4. Remember, in the denominator, whenever you multiply conjugates, it's always going to be the square of the first term minus the square of the second term. So in the numerator, these are like terms. The square root of 4 is 2, so this whole term becomes 16. So 6 plus 16 is 22 plus 16 the square root of 2. That's your numerator. The denominator is 4 minus, well, what do you get when you square this? Alright, let's remember squaring means doing this. So you get 16 the square root of 4, which is 16 times 2, which is 32. And 4 minus 32 is negative 28. Now, all of these numbers they can all be divided by a common term. If you leave the answer like this, that's okay, but I would like you to notice that they're all even. All even numbers can be divisible by 2, so you really get 11 plus 8 the square root of 2 over negative 14. A lot of times we don't write negatives in denominators. We would move the negative to the numerator. So which of these answers is the right way to write it? Technically, it's this one. However, this is an acceptable answer, and while you're learning to practice doing this, this would be an acceptable answer. And that is multiplying and dividing rational expressions or radical expressions.